This video will provide you with insight into the Agilent 81133A and 81134A 3.35 GHz high-speed pulse and pattern generator. The Agilent 81133A and 81134A are pulse and pattern generators with 3.35 GHz maximum frequency, fast 60 picoseconds transition times, and typically less than 2 picoseconds of total jitter. The 81133A is a single-channel generator, while the 81134A is a dual-channel configuration. All other features are identical. In this video, we will focus on the 81134A. Nevertheless, all setups shown here are also possible with the single-channel pulse and pattern generator. The Agilent high-speed pulse and pattern generators are designed for today's high-speed serial applications and designs, where signal quality and timing precision is required. Agilent's 3.35 GHz pulse and pattern generators are indispensable tools for any designer working on a high-speed digital device, including backplanes or any serial bus device. They allow tests to be performed so that designers can gain fast insight into their design, as they provide high-fidelity signals at unrivaled speeds. The Agilent 81134A also offers full control over the signal quality, which enables the designer to really stress the device under test by generating worst-case scenarios. The Agilent 81134A is the perfect solution for testing devices for today's high-speed serial interfaces, including PCI Express, Serial ATA, InfiniBand, and FireWire. Key features of this high-speed pulse and pattern generator include its broad frequency range from 15 MHz up to 3.35 GHz, the very fast rise times of less than 60 picoseconds, and of course, its very low intrinsic total jitter of typically less than 2 picoseconds. In addition, the Agilent 81134A provides several features which make it the perfect serial pattern generator. Examples are the deep 12 megabit pattern memory per channel, its PRBS capabilities, the burst modes, and the possibility to control the instrument remotely via several interfaces, including LAN and USB 2.0. The Agilent high-speed pulse and pattern generators are easy to use as they come with a self-explanatory graphical user interface. The top of the display always shows the main system settings, including operating mode and frequency. The lower part of the graphical user interface provides access to several sub-menus. In all menus, the important features and values can be directly accessed using the soft keys, which are located on the right-hand side of the display. The special twist and push button enables you to perform inputs using just one button. Additionally, any value can be changed by simply selecting, modifying, and accepting it in only a few steps. Numeric values can also be entered directly using the numeric buttons. Of course, the channel switches can be directly accessed from the instrument's front panel in addition to the access via the graphical user interface. The submenus can be accessed on the lower part of the screen. For example, restoring and saving settings, or modifying any output channel settings like the data pattern settings, etc. The data pattern submenu provides access to all pattern settings, including the length of the pattern, and also allows to directly change the selected data pattern. On top of that, the 3.35 GHz pulse generators provide several inputs to use an external clock source. To start the output on a special trigger signal, or control the delay of the signal, which will be shown later in this video. These pulse and pattern generators also come with graphical user interface pages that allow the modification of all settings that are required for the remote control interfaces, which are located on the back side of the instrument. These interfaces include GPIB, 10100 megabit Ethernet, and USB 2.0. We will use two different analysis instruments to show you some of the capabilities of the Agilent 81134A. The Agilent 86100C Digital Communications Analyzer with Jitter Separation, a sampling oscilloscope with up to 80 GHz bandwidth, and the Agilent 54850A 6 GHz Infinium real-time oscilloscope with 20 gigasamples per second. Using the Agilent 86100C's jitter separation capabilities, you can see the very low intrinsic jitter of the Agilent 81134A, less than 2 picoseconds in total. To generate worst-case scenarios, the Agilent 81134A comes with a delay control input. This allows a predefined amount and type of jitter to be injected into the output signals. The jitter is defined by an external modulation source that is attached to the delay control input. This allows any device to be tested on its jitter capabilities and jitter tolerance. We're using an Agilent 33250A arbitrary waveform generator as modulation source. It is simply connected to the delay control input. The delay control input sensitivity is selected, which also controls the maximum values of jitter to be added. The 81134A add a specific amount of delay to the output according to the voltage that is attached to the delay control input. Using the Agilent 86100C, you can see the pure output signal on the bottom, while we will add jitter to the signal that is shown on top. We are currently injecting 125 picoseconds of jitter by feeding a signal into the delay control input of one channel. Using the Agilent 54850A Infinium oscilloscope with the Agilent EasyJit software, you can see that the modulation source really controls the type and amount of the jitter generated. In addition, the oscilloscope shows the timing interval error waveform in blue. Below that, you can see the green waveform is captured from the jitter modulation source, which is also connected to the pulse generator's control input. These two waveforms are exactly matched, as the injected jitter is only defined by the voltage attached to the delay control input. With its burst capabilities, the Agilent 81134A allows you to test your serial devices by generating special data patterns such as initialization patterns or burst data transfers in order to test how the device under test really behaves. The data that is sent in these bursts can be set in the data pattern screen, including data pattern length and the bit sequence. Besides the instruments demonstrated in this video, Agilent provides solutions that cover all your test and measurement needs. Solutions are available for all applications from design to manufacturing. Examples are the pulse and pattern generators shown here that cover multiple test needs in the design cycle, and the Agilent 93000 SoC series chip testers. You see these in the background of this video. The 93000 SoC series is targeted for later phases of the product cycle, mainly complete device tests in high volume production. For more information, please visit our website at www.agilent.com/find/81134A.